Mechanical drawing, blueprint your ideal design. Hello everyone. Welcome to the micro class on mechanical drawing interpretation and tolerance fit. First, let's get familiar with the drawing. The first step is to read the title bar. From the title bar, we can see that the part name is a cone sleeve. The material is number 45 steel. The drawing scale is 1:1. The second step is to read the views. First, analyze the expression scheme. This part uses a section view to show the internal structure of the cone sleeve. Next, let's conduct a shape analysis. This drawing represents a sleeve-type part. The external shape is relatively simple. It consists of two cylindrical surfaces. The interior consists of an inner cylindrical surface and an inner conical surface. Among them, the taper of the inner conical surface is 1:5. The third step is to read the dimension annotations. Overall dimensions. The total length of the cone sleeve is 35. And the diameter is 538. Dimension benchmarks. The axial dimensions of this part are marked with the left end face as the benchmark. The radial dimensions are marked with the axis of the cone sleeve as the benchmark. The fourth step is to read the technical requirements. First, geometric tolerances. This drawing uses two shape tolerances, straightness and cylindricity. Second, surface roughness. For the cone sleeve, the outer cylindrical surface has the highest quality requirements. Its surface roughness RA value is 1.6 micrometers. The RA value for the remaining surfaces is 3.2 micrometers. Third, text notes. Sharp edges should be chamfered. When using views to express mechanical parts, the hidden lines on the contours should be drawn with dashed lines. If the internal structure of a mechanical part is very complex, there will be many dashed lines in the view. Too many dashed lines affect the clarity of the view and make it inconvenient for us to draw, read, and annotate dimensions. For the machine part shown in the figure, the left half of the base plate has a U-shaped groove and a stepped hole. The right half has stepped holes of different sizes. And there are also keyways inside. This results in many dashed lines in the front view. If we want to better express these structures, what method should we use? Imagine a plane cutting through the middle of the machine part. This imaginary plane is called the cutting plane. We remove the part between the observer and the cutting plane. Then, we project the remaining part onto the projection plane. At this point, the various holes and grooves inside the machine part become visible. To distinguish between the sectioned view and other views, we draw section symbols on the parts where the cutting plane contacts the solid body of the machine part. The drawing produced by this method is called a section view. Let's summarize the formation process of a section view together. Imagine using a cutting plane to cut through the machine part. Remove the part between the cutting plane and the observer. Project the remaining part onto the projection plane. And draw section symbols in the sectioned area. This can be simply remembered as cut, remove, project. How exactly should we draw a section view? Let's take a look at the steps for drawing a section view. First, determine the cutting position of the cutting plane. As shown in the diagram, the part is symmetrical front to back. Therefore, we cut it along the centerline. Second, imagine which part is removed. We remove the part between the observer and the cutting plane. Determine the shape of the section area. The section area is the part where the cutting plane contacts the solid part of the component. The U-shaped groove on the left half of the base plate does not contact the cutting plane. Therefore, there is no section area there. However, there is a solid part between the U-shaped groove and the stepped hole. Therefore, this part belongs to the section area. At the same time, there is solid contact between the stepped hole on the base plate and the stepped hole on the right half, as well as on the right side of the stepped hole on the right half. Therefore, these parts all belong to the section area. After clarifying which parts are cut, we can see the projection. Pay special attention to the connection lines between the stepped holes and keyways. Finally, draw section symbols in the section area. Different materials of the component require different section symbols. Section symbols are usually called section lines when it is not necessary to indicate the material category in the section area. The section symbol can be represented by a general section line. The general section line is a thin solid line. It is best to make it at a 45 degrees angle with the main outline of the drawing, or the symmetry line of the section area. For the section areas of the same object, the drawing method of the section lines should be consistent. When the drawn section line is parallel to the main outline of the drawing, or the axis of the section area, the section line of the drawing should be drawn at a 30 degrees or 60 degrees angle to the horizontal. But its inclination direction should be consistent with that of other section lines. This is how we draw a section view. So, are there any special requirements for section views? What annotations do we need to make? Next, let's learn about the annotations for section views. The annotations for section views include 3 parts. The first part is the cutting line. The cutting line indicates the position of the cutting plane. It is represented by a thin dot dash line. Generally, it can be omitted. The second part is the cutting symbol. It indicates the starting, ending, and turning positions of the cutting plane, as well as the projection direction. It is usually represented by a thick short line to indicate the position of the cutting plane. The line width of the thick short line is 1 or 1.5 times that of the thick solid line. The length of the thick short line is about 6 to 7 millimeters. To ensure clarity, the thick short line indicating the cutting plane must be clearly separated from the outline of the drawing. Don't cause any misunderstanding. On the outside of the thick, short line, draw an arrow indicating the projection direction. The third part is the name of the section view. Above the section view, use uppercase letters to label its name, such as X-X. And write the same letters on the view where the cutting symbol is marked. For example, a -A in the diagram. Annotations can be omitted in the following 2 cases. One is when the section view is arranged according to the basic view relationship, the arrow can be omitted. The second case is when a single cutting plane passes through the symmetrical plane of the component, and the section view is arranged according to the basic view relationship. No annotations are needed. When drawing section views, there are many difficulties we need to master. Let's go through the key points we need to pay attention to. First, we say that a section view is imaginary. A view created by cutting open the machine part. Therefore, besides using the imaginary cutting method for section views, other views should not be affected by the section view. We need to draw complete shapes. As shown in the diagram, the front view uses the section view method. while the top view still shows the complete shape. Second, how do we choose the cutting plane when drawing section views? We use the section view method to clearly express the internal structure of the machine part. Therefore, our cutting plane generally chooses to pass through the symmetrical plane, or basically symmetrical plane of the machine part. This ensures that no incomplete elements appear in the section view. Third, when drawing section views, all visible outline lines behind the cutting plane should be fully drawn without omission, as shown in the A-A, B-B, and C-C section views in the diagram. Fourth, section views are used in conjunction with other views to express the internal structure of an object. If a part has already been clearly expressed in other views, then the dashed lines in the section view can be omitted. For example, the dashed lines for the projection of the base plate in the diagram do not need to be drawn in the section view. Similarly, if a part has already been clearly expressed in the section view, and the projection of this part's structure in other views is a dashed line, then the dashed line can also be omitted. However, if a part is not clearly expressed, a few dashed lines can be drawn. That's all about section views. That's all about our class. Thank you.